Today's lesson is 6.5, Graphing Rational Functions. A rational function is a function whose rule can be written as a rational expression. Here is a most common way of thinking of it. F of x equals p of x over q of x, where p of x and q of x are both polynomials. And of course, q of x cannot be equal to 0 because it is in my denominator. And remember, we just cannot divide by 0. The parent function of my rational function is 1 over x. It is called a hyperbola. It has these properties. The x-axis is what is called a horizontal asymptote. And so there's an imaginary line right there, which is y equals 0. And then the y-axis is also a vertical asymptote, and this is the equation x equals 0. The domain and my range are all my real numbers except where these asymptotes are located. The two parts of my graph, this one and that one, are called branches. To be an asymptote is just a line that a curve approaches but never touches as it heads towards infinity. So let's just look at the x-axis right here, which was our asymptote. Notice this curve and this curve are never really touching it. They're getting close. They're getting really close, right? Like it looks really close, but it's just never going to touch it, okay? All right, I can think of this as a second form of my rational function. And this is quite helpful because it's going to help me find my asymptotes and it's going to help me find my domain and my range. So A is going to be the number that's on top of my rational expression. H is going to be down here with the x. And notice that it does say minus, so H is actually trying to trick you. H looks like it's negative, but he's really positive. And H looks like they're positive, but they're really negative. And then K is being added or subtracted behind the rational expression. And K is not trying to trick you. K looks positive, so K is positive. K looks negative, so K is negative. All right, my asymptotes are at x equals h and y equals k. This is the beauty of this form of the rational function, because now I just have to figure out what h and k are, and now I know where my asymptotes are. My domain is going to be all real numbers except h, because this is where my denominator is equal. I can do that better. There we go. Equal to 0. And remember, you just cannot equal to 0. So any number here that would make this denominator equal 0, like 2 minus 2, then you would say that your domain is not that number. Okay? Your range is going to be all of your real numbers except for whatever k is. If your a value on the top of your rational expression happens to be negative, then your graph is reflected across the x-axis. If the absolute value of this a value is greater than 1, then it results in a vertical stretch. And if the absolute value of this a number is between 0 and 1, then it results in a vertical compression. Let's go ahead. I've got two examples of graphing to show you, and I'm going to be referring to your ALEKS assignment as well. So here is our first equation. We're going to graph it. We're going to find the asymptotes. We're going to find the domain and the range, and if there are any zeros. So here is my function right here. And I don't need to go to Desmos right away. I can go ahead and I can start finding A, H, and K. So remember, A is always going to be this number that is on top. So my A is equal to -2. My H is going to be the number that's down here with my X, because remember it was X minus H. Well, there's nothing being added or subtracted to my x value, so it is going to be 0. And my k value, remember my k value should be right here because it said plus k, but there's nothing there. And so I'm going to say that k is 0. I need to go ahead and do this because now I know where my isotopes are. I know that I have an isotope at x equals h. So I've got one at x equals 0. And I know I have one at y equals k. So y equals 0. If I were to graph them, y equals 0 would be right here. And you actually are going to have to graph them in Alg2. And Alg2 kind of shows you how to graph them. Okay, and there's your x equals 0. Okay, so there's your two isotopes. All right, for the zeros, what you would normally do is you would just set the f of x equal to 0 and you would solve this equation. But since you got 0 for these, since you got 0 here, and your x-axis is an isotope, there are actually no zeros. There are no zeros because what a 0 really is an x-intercept. And your graph is not going to touch the x-axis, right? There's your x-axis right there. This graph isn't touching it, so there are no zeros to this function. All right, the last thing is to find the domain and range, and I'm going to zoom out just a little bit. There we go. Because I'm going to use my x for my domain, and I'm going to use my y for my range. Remember that your domain is all your values except for whatever x is. So if I were to write it as an inequality, it would be x is less than 0 or x is greater than 0. If I were to write it as set notation, I would use my squiggly bracket, x, such that x does not equal 0, and finish with a squiggly bracket. If I were to write it in interval notation, I would start with negative infinity, which always gets a parentheses, comma 0, and I'm using 0 because it is h, union 0 to positive infinity. Now I'm using the union because it does have the two different branches, and I'm using the parentheses because 0 is my isotope, okay? To find my range, I'm just going to use my y, and it's 0 as well, so I'm going to say y is less than 0 or y is greater than 0. My set notation is going to look the same, except I'm going to change my variable to y, because that's the range. And my interval notation will look exactly the same because they're both 0. There we go. All right, the last thing I need to do is I need to go ahead and draw my two branches. Now, what Alg2 is going to ask you to do is it is going to ask you to do 2 points. It's going to ask you to put your isotopes, and then it's going to ask you to put your two points on each of your branches. Okay, so there is my graph. And remember, you can use the little widget right here to go ahead and get yourself a table. And the nice thing about this is they've already got the points. There's 2 on that branch, and there's 2 on this branch. Now, Alg2 calls them the 2 pieces of the graph, but remember they are the branches. So let's go back and let's plot those points. I think I'll put it a little bit smaller. It was -2, 1, and -1, 2, and it looked something like this. Remember, Alg2 is going to go ahead, and once you plot it, it will connect them together for you. 1 and -2, and 2 and -1. All right, we have one last one left. Let's go ahead and take a look at it. So notice this graph is a little bit more challenging. My A value is going to be right here in the numerator. So my A is going to be 1. My H is right here. And remember, he's trying to be tricky. I think he's -5, but I know he's really +5. And my K value is right here, not being tricky. He's not tricky. There we go. My two acetopes, remember, X's acetope is at H. So it would be X equals 5. And if I were to graph that, I would come to where X is 5 and I would just go straight up and down. There's going to be a part in Alex where it'll let you graph that for it, okay? And my other acetope is at Y equals K, so I know it's at Y equals 2. So I find where Y is 2, there it is, and then I just go straight out. There we go. Okay, my zeros. So for this one, I will actually have to solve it, and I'm going to try to do this as best I can. Okay, so I went ahead and I changed my f of x to 0, and I'm going to go ahead and solve this equation. So I'm going to go ahead and draw a line through there just to make sure that I'm keeping everything nice and even. So I'm going to subtract my 2. And then I'm just going to go ahead and I'm going to crisscross multiply. So I'm going to multiply this times this, and then I'm going to multiply this times that. Remember that whenever you have a number like -2, you're going to put it over -1. So for the blue, I would have -2 times x minus 5, and for the purple part, I would have 1 times 1, which is 1. I'm going to go ahead and distribute the -2, which gives me -2x, and -2 minus 5 would be a positive 10. Oops, I forgot the 1. There we go. I would simply solve this two-step equation in the normal fashion. Equals -9 divided by -2. A negative divided by a negative would be a positive. And so there's my 0, or I could even say it's at 4.5. I could even say my 0 is at 4.5. All right, my domain and my range. Now remember, my domain goes with my x value, which is 5. So it's everything but 5. So x is less than 5 or x is greater than 5. That's how you always write it as an inequality. In set notation, you would do your squiggle x such that x does not equal 5. That's all you've got to do. And for interval notation, you're going to start with -infinity and go towards your h value, parentheses, union, your h value to positive infinity. The range is just going to change to the y. So my y was equal to 2. I just moved it down so that I could see it right here. So y is less than 2 or y is greater than 2. My set builder notation, y such that y does not equal 2. And for my interval notation, -infinity to 2, union 2 to infinity. You never want to put a bracket with the 2 or the 5 for either of your interval notations, because that is where your acetope is. So it's actually, the graph is not touching it. Let's go ahead. The last thing we need to do is find our points to plot. And I have to admit, this one isn't the best, but here we go. -5. Make sure you get out and then add the 2 at the end. There we go. So remember, you can come here to your little widget and you can click on your table and it's going to make a table for you. I'm going to go ahead and get rid of this stuff that Desmos has picked for me. And I went ahead and I tried to find nice points, but this was one of the nicest points I could find on this branch, and then this one. Now 4 and 1 is a really good point, but the only other one that I could find was 3 and 1.5. The ones that you get in Alex should be much better. But Alex is going to ask for two on each of the branches. But remember, not Desmos, Alex calls them pieces. So it wants the 2 on this piece and the 2 on that piece, two on each of the branches. All right, that's the best I could do for these. Let's go ahead and see where those graphs would be. 3 and 1.5 would be right about there, and 4 and 1. And this is the piece of the graph. This is the branch that looked something like that. And then 6, 3, and 7, 2.5. And this was the branch that looked like that.